Right. Hello, everyone. This is Kshitij from Responsi, and today we're going to be doing a short tutorial, kind of like a beginning tutorial on limits, which are essentially the basis of all of calculus. Right, so let's get started. So what I have here is kind of like a graph, a grid of the x and y axes, which undoubtedly you're familiar with. And here I'm going to enter a function. Let's just take an arbitrary function, y equals x squared for that matter. So you see this little pink graph, that is where you're seeing y equals x squared. Now, the interesting question in algebra is basically what value of y corresponds with each value of x. Alright, so that is a pretty nice question to ask in algebra, but in calculus, we can actually go a step further. We can say, what are the values around each y value that corresponds to each x value? So that is where the informal definition of a limit comes into play, and that's what we're going to be talking about today. So let me open up my math program, and so we have here essentially a graph, which is a function. To represent a limit, we use this notation, right? The limit as x approaches a for a function of x is equal to some value L. So basically, what happens is, in the function, as x gets closer and closer and closer and closer to a, that is where you're getting this limit L. Alright, so let's do a sample right here. Let's take the limit as, well, very simple example, the limit as x approaches 0. So we use the same notation, limit as x approaches 0 of x squared. That is your function. Your f of x is equal to x squared. So let me make that clear again. So your f of x is equal to x squared, and this is the limit that we're looking for. So basically what we're asking is, what value of y does the function approach as x gets closer and closer and closer to 0 from both sides, from the negative side and from the positive side. Alright, so let's start off with values that are close to 0, right? Let's take x and f of x. Let me make this a little bit bigger so you guys can see it. Right, so that's x and that's f of x. Okay, let's take the value x equals -1. At -1, y is of course 1. It's -1 squared, which is equal to 1. Now let's get a little bit closer to 0. Let's take -0.5. -0.5 squared is equal to 0.25. Note that this is a positive value, that the Excel file is rounding it off to 0.3, but it's 0.25. That is the value, right? 0.25. So as you see, we're clearly getting closer to 0. As x is decreasing, the y is also decreasing. Let's get closer to 0 in the x. -0.25. This is going to give us positive 0.0625. The Excel spreadsheet is going to, of course, round this off. But as you see, the y value decreased again, which makes perfect sense since as you can see from the graph, the y values are decreasing as you're coming closer and closer to 0. Let's take a value even closer to 0, 0.1, negative 0.1. This is going to give you a y value of 0.01. You see, as the Excel spreadsheet, it already rounds it off to 0. That means as you're getting closer and closer to 0 from the negative x side, your y values are also approaching the value 0. Now let's take it from the opposite side, just to convince ourselves that it is, of course, that the limit as x approaches 0 of x squared is equal to 0. We saw this from the negative side, but for any given limit, you have to prove it from both sides. Notice that I use the word proof because there will be some proofs involved as we go on with more response size limit tutorials. So let's just do it as we did it for the x. This is the negative x, and this be the positive x. Right? Let's try 1. It's going to be 1 squared, which is equal to 1. 0.5. Positive 0.5. It's going to be positive 0.25. 0.25. This is going to give you 0.0625 and 0.1, which is going to give you 0.01. As you see, from the positive side, you're also approaching 0. So with certainty, for at least this problem, graphically, you can say that the limit as x approaches 0 of x squared, the function x squared, is equal to 0. So basically, what we have shown is from both sides, as the x values of this function approach 0, the y values also approach 0. Alright, that's going to be it for this short clip, and we'll return in the next one. Thanks.